welcome back. Today's video will be practicing least common multiple word problems. Okay, and the first one, it says, Josie and her friends made dinner reservations at 2 local restaurants on 2 different days. While the first restaurant sat all the friends in groups of 9, the second restaurant sat all the friends in groups of 3. What is the smallest number of people that could be in the group? Okay, so we know we're looking for the least common multiple because with the least common multiple, we are listing the multiples of each number. So here, this on 2 different days indicates we're gonna have 2 different groups. And you'll see here, we have a group of 9 and a group of 3. So we're going to use 9 and 3 to find, as you see here, it asks you what is the smallest number of people that could be in the group. Now, if you remember, with least common multiple, you list the multiples of each number and then find the smallest number that appears in both lists. So this is how we will solve this. So, groups of 9, remember, the multiples of 9 starts with 9 times 1, which is 9. 9 times 2, 18. 9 times 3, 27. 9 times 4, 36. 9 times 5, 45. Okay, and then we have 3. So we'll begin with the multiples of 3, which will be 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And then we have 3 times 4 is 12. 3 times 5 is 15. Okay, so now that we have our list, we are looking for the smallest number that appear in both lists. That will be 9. See it? So the LCM, or the least common multiple, of 9 and 3 is 9. That's it. Let's try the second one. So, a man is arranging green blocks in groups of 8 and purple blocks in groups of 6. If he has the same number of green and purple blocks, what is the smallest number of each color that he could have? So you see, it's the same thing that we're doing here with the LCM. It's asking you here, what is the smallest number of each color that he could have? Now, for our list, we know he had, it says here, groups of 8 and groups of 6. So we will be finding the multiples of 8 and 6. And with that, we'll know that will be the smallest number of each color that he can have. Okay, so the multiples of 8. You know, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And then 8 times 5 is 40. When we look at the multiples of 6, it's 6 times 1 is 6, and then 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. So, now that we have our list, we are looking for, as you know, the smallest number that appears in both lists. So if we look here, we can see that the smallest number of each color that he can have is 24. So the least common multiple is 24. That's the smallest number of each color that he could have. Okay, so it's pretty simple, same steps. Let's look at one more. So the last one, Zora realizes that the number on the classroom door is divisible by 2, and her classmate points out that it is also divisible by 10. What is the smallest possible number that could be on the classroom door? Okay, so again, we see divisible by 2, divisible by 10. okay? This will be our multiples, 2 and 10. So let's start with 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And then 2 times 4 is 8. 2 times 5 is 10. Okay, and the same with 10. We go 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. 10 times 5 is 50. So within our list, we're looking for the smallest number that appears in both, right? And that number is actually 10. See that? So your least common multiple is 10. And the answer to this question, what is the smallest possible number that could be on the classroom door, is 10. That's it. I'll see you on the next one. Bye.